Okay, it's live. All right. So here's the problem, and I wish we could zoom in on this. Let's see. Zoom in. I have to use that. Nothing magic search. I didn't even say that long. Oh well. Make believe you can read that. I'll read it to you. So a balloon is rising vertically above a level straight road at a constant rate of 3 feet per second. Okay, so balloon goes up 3 feet per second. So if y is the height of the balloon, what would we call the 3 feet per second? Yeah, it'd be dy dt. Okay. Just when the balloon, and I'll write all this down in just a sec. Just when the balloon is 120 feet above the ground, a bicyclist moving at a constant rate of 15 feet per second passes under it. How fast is the distance between the bicycle and the balloon increasing 6 seconds later? So they gave us a snapshot in time, and they're saying use that snapshot in time to predict what happens in the future. So we have to write down how everything's related here. So minimize this a bit. So let's see. That out of the way. All right, draw a triangle. Let's draw a nice purple triangle. Okay, so, and then what color should our balloon be? I wanted a red balloon earlier. So here's my red balloon floating up in the sky. There's a little black basket underneath. Attaching it. Okay, and here is my straight level road to the best of my artistic ability. I believe it is straight and level. All right, so let's see. This height right here is what we're calling y. And we were told that the balloon is increasing at a constant rate, so dy dt is always equal to, I think it was 3 feet per second. Does that sound right? So we know dy dt. Now, do we know why? Let's see. What did it say about why? They said that just when the balloon was 120 feet above the ground, a bicyclist passed under it. Okay. So when the y was equal to 102 or 120? 102, thank you, good job. 102. The bicyclist was exactly underneath it. So here's my bicycle man flying along in this direction. So we'll call this direction x. How fast was Bicycle Man moving? Bicycle Man was moving at 15 feet per second. Later we could figure out how many miles per hour that is. So is the 15 feet per second, is that x or dx dt? What do you think? No. X would just be feet, right? So feet per second would have to be dx dt. Okay. So when x is equal to 0, dx dt, and by 0 I mean directly under the balloon, dx dt is equal to 15 per second. And then they tell me 6 seconds passes. Okay, so I count along here, 1, 2, 3, 4, 5, 6, and let's make the future Mr. Bicycle Man green. He's somewhere over here. So this is 6 seconds later. Mr. Bicycle Man is right there. How far away from where the balloon took off is Mr. Bicycle Man now? Can you figure that out? 6 seconds later at 15 feet per second, 90? That's right. 6 times 15. So this right here should be 90 feet. So 6 seconds later, he should be 90 feet along. Now, the balloon was at 102 here, but it's climbed since then because it kept going up. So if it's climbing at 3 feet per second, how much higher did it get after 6 seconds? So 3 times 6 is 18, right? Because he plus, yeah, at 120, right? So plus the 102. So that puts us now at 120 feet. So 6 seconds elapsed. The balloon is moving very slow compared to the bicyclist. So this snapshot in time, coincidentally, gives me this beautiful right triangle. So I'm just going to redraw this right triangle down below without all the sketching in between. And let's put it in a nice boring black. And I didn't even attempt to make that to scale. Oh my gosh. Let's make it better. So I just undo those lines. All right. So when the height of the balloon is 120 feet, the bicyclist will be 30 feet away from the base. Maybe that's right around here. Or sorry, 90 feet away from the base. And then we are being asked, this right here would be the distance between our little bicycle man here, EM for bicycle man, and hot air balloon. Hot air balloon is up there. So what we've been asked to figure out is, can we discover what is the rate of change of the distance between them? So what they want me to find, let's put that in red. We were asked to find how fast is the distance between, sorry, I got that DD here, that's kind of bad. Okay, we call this D instead. How about H for hypotenuse? Because this is a right triangle. Yes. Cross that out. We're going to call that an H. So that means we'll cross that sucker out there. Isn't there an eraser here? Oh, check it out. There's an eraser and everything. dH dt. Okay. H for hypotenuse. So we need to figure out what is dH dt. All right, so let's do that. Well, let's put in some variables here. The 120 represents my y. The 90 represents my x. This is a right triangle. So how are x, y, and h related here? Yeah, Pythagorean theorem. Pythagorean theorem tells me that y squared plus x squared equals h squared. So your job right here, because we need to find dH dt, the only way I can do that is by implicitly differentiating. So if you guys could do that for me and tell me what you get. Implicitly differentiate this equation, like we did with the balloon and the area equation. Oops, I didn't spell that right. Okay, write it down, tell me what you get. And So first, you got this written. Yeah, so you just want to start taking derivatives moving left to right. What's the derivative of y squared? 2y. Yeah. And then the chain rule says you have to tack what onto it? Kind of like here, we have to tack on dy dt. Y is changing over time. So I'll get it started. Kyle, you're going to try writing this down too? All right, so derivative of y squared is 2y, but y is changing over time, so I need to multiply by dy dt. And continue. What comes next? It's after 2y dy dt. Yeah, correct. So derivative of x squared is 2x, but since x is a function of time, chain rule says I have to multiply by dx dt. All right, Elizabeth, what's on the other side? Beautiful, 2h dh dt. Yeah. So usually I don't like to mess with these too much, but every term has a 2 in it, right? I could divide the 2's out. Might as well do that. It makes it a little easier. So I could divide both sides by 2. And then I'm going to get y dy dt plus x dx dt equals h dh dt. And let's see, does this thing have a highlighter on it? I thought it did somewhere. Probably hiding down here. Can I move you? Ah, thank you. Highlighter. Okay. And ultimately, I was asked to solve for dh dt. Now, before I do that, I like to plug in any numbers I know. Like, do we know what y is? At the snapshot in time of 6 seconds later, we figured out that y is 120. So let's plug it in. So let's plug in everything we know. So let's see. Switch back to my regular pen. Y is 120. Do we know what dy dt, the rate the balloon is rising? I believe that was 3, right? So 120 times 3 plus x at 6 seconds later, the bike got 90 feet away from when it was below, times dx dt. How fast was the bicycle moving? Anybody remember? 15, right? 15 feet per second. Beautiful. On the other side, do we know the hypotenuse of this situation? 6 seconds later, the distance between the bicycle and the balloon right here. I didn't write it down, but we could figure it out, couldn't we? And we know the Pythagorean theorem. So figure out what h is here. Whip that out quick. See what you get. See, I got 120 squared. I got a 90 squared. And I'll have to take the square root of those puppies, which I really feel like doing in my head. So I'm going to ask Google. What is it? 150 is what it comes out to? Okay. Or I could just ask Jesus. Anyone else get that? Get confirmation on that. Always want to make sure we're checking our work. Let's go ask Google here. What is 120 squared plus 90 squared? Google says it is 22,500. And if we take the square root, anybody know how to make Google do a square root? Type SQRT, and Google will take the square root and say it is 150. Right on. Good job. So Google is my calculator when I don't have one immediately available, but I do have a web browser. All right, so 150 is correct. So let's go back down to our equation. We now know that h is 150. The only thing that's unknown right now is what I was asked to find, dh dt. Can I find that easily now? I just multiply, add, and then divide by the 150. Boom, I'm done. Okay, so tell me what is dh dt, please. Please do that arithmetic. Is 1710, and so next I want to divide that by 150, and I get 11.4. Anybody else get that? Get that, Elizabeth? Awesome. Okay, what does the 11.4 mean, though? Okay, what? Oops, it's not a fraction yet. I'm getting ahead of myself. Eraser. So what does H mean here? What does H mean in this particular problem? What does it represent? It's that distance between the bicycle guy and the balloon. Right? It's a distance. It's feet. Everything else was in feet, so I'm assuming this is in feet. Okay, so it's a distance in feet. So DH means change in feet. What is DT here? Change in time, and what are our time here? Measured in? Seconds, yeah. So 11.4 must be 11.4 feet per second. So here's the hard part of a related rates problem. I don't know if Pete's as picky as I am in these classes. I like somebody to write a sentence that I could tell to my mother and she would get it. What does the 11.4 mean, given that we have a bicycle and a balloon? Let me write a sentence that would tell my mother what that means. Give it a shot. Write down anything. Don't worry about being right. Just give it a shot. And I'll give you what I would put for a sentence, which isn't necessarily the best one. Kyle, give it a try. Play along. Come on. You can write a sentence. Oops, I can't spell bicycle. I hate that. I ride one every day. Ah. Oops. Okay, so I don't know if this is the best sentence, but I think it works. So I wrote 6 seconds after the bicycle man passed under the balloon, they were moving apart at 11.4 feet per second. Now, just at that instant, right, if I look later, it's going to be slightly different because the triangle changed shape. But that at that instant, that's how fast they were moving apart. So any kind of variation on that. So the key here is it's the rate that they were moving apart exactly 6 seconds after he passed under, right? Because we have a snapshot in time. That's all related rates give us. If somebody says, give me another time, I got to refigure it. It's always changing. Always changing. Given any snapshot, I can make a prediction about how things changed. So that's what. So the problems always work the same way. You have to have some kind of way to relate the variables. So we related the variables right here. Why am I trying to draw with the mouse? Given that, I then try an implicit, so one, I have to have an equation, right? Got to have that equation. Two, I have to be able to differentiate. That always involves the chain rule. Then I need to be able to fill in everything but what I want. And if I wasn't given enough information to do that, I can't make any predictions. Right? So we have to have some measurements in order to make predictions about unknown ones. So I have to be able to fill in pieces. So implicit differentiation requires a chain rule. Step 3 is to just fill in the pieces. And pray you have enough pieces. Now the cool thing about this online program is at this point in time, we just did a lot of really cool math, but I have no idea if any of it's right. Right? We did double check each other's calculations, right? So we got that checked. But how do we know any of this is right? Well, 2 ways I can check that. One, I can just go back to the program and say, hey, is my answer right? So it wants to know, let's see. Oh, they called it S. So S is increasing by, what did we figure out? 11.4, yeah, so we should be able to type 11.4 feet per second. And somewhere down here, there's a little button that says, check my answer. But before I hit that button, I like to look at my work and be able to check it myself. Because is there a check my answer button on your test? No, you are your check answer button. So, right, so you want to make sure you check your work first. So I'm going to resist hitting that. I'm going to go back here. All right, let's see. Did I draw my triangle right? Is it really a right triangle? Well, they said Bicycle Man was directly underneath the Balloon Man at one point in time. And they also said the road was straight and level. And the balloon was going straight up. What that means is that this line right there is definitely perpendicular to my road. Okay, that's a good sign. Bicycle Man moved along, right? And at this 6 seconds later, he's right here. Balloon Man rose up a little farther. He's up here. Does that make a right triangle? Yeah, because I have a right angle right there. Okay, that's good. Let's see. Did I put the x, y, and the h in the right places? The trick with the Pythagorean theorem is the biggest side always has to be sitting by itself. Did I put the biggest side by itself? Yeah, h is the biggest side, and it's by itself. Okay, so I set that up right. Did I take my derivatives right? Is the derivative of y squared 2y? Yeah, that one's pretty straightforward. Chain rule says multiply by dy dt. That all looks good. Okay, so the only questionable part really is the square root right? Well, we checked that a couple of different ways, and we asked Google. And Google's always right, isn't it? Make a heck of a lot of money, they better. All right, I think we're good. I think we're all right here. So let's go back and check it. Check answer. Hey, good job. My favorite is when it says fantastic. Ever get any fantastics when you do your homework? I like fantastic better. All right, that was pretty cool. So are the related rates starting to feel a little better? Okay. Cool. What time does this class go till? 1:10? Oh, we're out of time for fun. What's that? I was supposed to talk about what's called linearization. So let me give you a 5-minute intro to linearization. And I'm going to turn off the recording to do that. How do I do that? Down here, stop sharing. Okay, Hangouts.